When dealing with acidic and basic compounds in organic chemistry, the procedure you're working with might call to neutralize it. A neutralization reaction is when an acidic substance has a base added to it in a quantitative amount, and vice versa, to neutralize the pH. The H plus and the OH ions form water, and the ionic atoms, such as sodium and chloride from HCl and NaOH, form a salt solution. The neutralization that we will specifically be focusing on is the neutralization of an acid wash and a base wash from the liquid-liquid extraction experiment from video 1. This is done to separate the organic compound we're looking to extract, and the reaction between the acids and the bases will create a solid precipitate inside the flask. This procedure calls for a specific concentration of HCl and NaOH to neutralize the other. The base wash uses 6 molar HCl to neutralize 60 milliliters of 3 molar NaOH, and the precipitate will be benzoic acid. For the acid wash, 6 molar NaOH is used to neutralize 60 milliliters of 6 molar HCl, and the precipitate will be p-bromoaniline. I found through testing that using 60 milliliters of both 6 molar HCl and NaOH neutralizes both the acid and the base wash, but as a general benchmark, you want to either use pH strips to test when the pH of the solution is around a value of 7. When the pH is 7, there is little to no H plus or minus OH ions left, as they've all reacted to each other to form H2O. Here's the rules for calculating pH and PaOH. To test this, let's say you had a really small number, like 1 times 10 to the negative 7th. If this was the molar concentration of H plus ions, and you put this in the pH formula, guess what it would come out to? 7, that's right. And thus, the smaller the concentration of H plus or minus OH ions, the larger your pH will be, up to 14. Thus, when a solution is neutral, the pOH and the pH are both 7, as almost all of the H plus and minus OH ions have reacted with each other to form water. Here's what it looks like when the solution is neutralized. You'll see it turns white, but most of the liquid inside of the flask is actually clear. The solid precipitate is the part that makes the solution white and will begin to solidify more once put in an ice bath. And here's the neutralization of the base wash. Again, benzoic acid is a white solid, so the solution turns white as the precipitate forms. As for why we added 6 molar HCl to 3 molar NaOH, it turns out you need an acidic solution to convert benzoate to benzoic acid, as its pK is around 4, which means it's half protonated at pH 4 and will only be fully protonated below this pH. If not enough of either acid or base is added, the precipitate will not fully form. Now that I've shown you what the procedure is called for, I want to get a little more conceptual and work through with you how you can calculate how much acid and base you need to neutralize a more simple reaction. Let's just say we have 60 milliliters of 6 molar HCl. On its own, that needs to be neutralized. To neutralize it, a base in a specific quantity needs to be added so that all of the H plus ions react with the basic ions to form water. If we're using NaOH, then this would be a 1-to-1 molar ratio in the stoichiometric equation. If it was something like barium hydroxide, the molar ratio would be 2 moles of HCl per 1 barium hydroxide mole. We'll calculate how much we need of both NaOH and barium hydroxide. Now, to calculate the moles of our HCl on its own, we need to multiply the molarity of our HCl, which is 6, by the liters of the solution, which is 0.06. This leaves us with a solution of 0.36 moles. This means we would need 0.36 moles of sodium hydroxide to neutralize the acid, and 0.18 moles of barium hydroxide to neutralize the acid. This means two things. Depending on how many liters of solution you want to use, you can either have a larger molarity with less liters of solution, or vice versa, more liters of basic solution with a smaller molarity. If we were to use the same molarity, 6m, we would need to calculate how many liters we need for each base. To do this, divide your moles by your wanted molarity, then multiply by 1000 for the conversion to milliliters. For barium hydroxide, if you wanted the same amount of liters, which is 0.06, you would simply cut the molarity concentration in half to 3m. Thanks for watching, and I'll see you in the next video.